All right, welcome to the Explainer. Today, we are diving into something that's famous in the Prolog world for being just as powerful as it is tricky to wrap your head around. I'm talking about definite clause grammars, or as you'll see them, DCGs. Now, if you've ever tried to learn these and felt, well, just like this, you are so not alone. This quote, it's straight from a programmer on Reddit, and man, does it hit home. It just nails that feeling of frustration when a concept just won't click, you know? Everything feels vague, the code looks like magic, and you're just stuck. It's a super common hurdle, and it's exactly what we're going to clear up today. So let's start by framing the problem, right? We're going to treat learning DCGs just like we're solving a puzzle. One that, let's be honest, trips up a lot of really smart programmers. And for so many people, this is exactly what it feels like. You've got all these pieces laid out in front of you. You've read the tutorials, you've seen the code, but it feels like one crucial piece is just gone. You can tell they're supposed to be powerful, but you just can't see how it all fits together. And this quote right here, it gets to the absolute heart of the problem. So many tutorials, they just jump into these super complex examples way too fast, and they leave you in the dust. What's really missing is that solid foundation of simple, clear examples that you can actually build on. So guess what? That's exactly where we're going to start. So this brings us to what I think is the first huge aha moment. We got to ask a really basic question. What is a DCG anyway? Is it some kind of brand new magical feature baked into Prolog? Well, the answer, it's actually surprisingly simple. Here it is, the big secret. DCG notation is just syntactic sugar. That's it. It's a shorthand, a convenient way to write code. It lets you write something that looks like a simple grammar rule, but behind the scenes, Prolog is handling all the messy, tricky stuff for you. You get to focus on the logic, not the plumbing. Okay, let's pull back the curtain and see what's really going on. On the left, you've got this nice, clean DCG rule. Looks simple, right? But on the right, that's what Prolog is actually seeing. It translates your code into that. That little arrow, the DSW thing, it's a super clever shortcut. It automatically injects 2 extra arguments into every single rule. And those arguments, they create this invisible chain that passes the list from one part of your grammar to the next. That, right there, is the secret sauce. So we know that DCG rules are really just a disguise for normal Prolog code. But what are those hidden arguments actually doing? To get that, we need to pop the hood and look at the engine that makes it all run. The secret ingredient here is a really clever technique called difference lists. Instead of working with lists the old-fashioned way, you work with the difference between a start list and an end list. So think about those hidden arguments, A and Z. The rule is basically saying, hey, the piece of the sentence I care about is whatever is in list A but is not in list Z. It's a little bit of a mind bender at first, I get it, but this is the key to how DCGs can chew through sequences so efficiently without having to create tons of new little sublists all the time. This insight from the original Reddit poster is just brilliant because it really gets to the why. This whole difference list approach is what lets you connect your grammar rules together just like links in a chain. One rule grabs the list, does its job, and then passes the rest of the list, the remainder, to the very next rule. It's so much more efficient than constantly chopping lists up and sticking them back together. Let's walk through it nice and slow. Imagine our sentence rule. The first part, the noun phrase, it gets the whole list, let's call it A. It finds a noun phrase right at the beginning and then says, okay, I'm done. Here's the rest of the list, which we'll call B. Then, and this is the cool part, that exact list B gets handed over to the verb phrase. It finds a verb phrase at the start of B and passes on whatever is left over, Z. See? It's this beautiful, seamless handoff from A to B to Z. Okay, so theory is one thing, but seeing it in action is another. Let's directly answer that plea from Reddit for some simple but still powerful examples that you can actually sink your teeth into. This is where the light bulb really starts to go on. Okay, let's start with this gem from the Reddit thread. It's this tiny recursive rule that checks for balanced A's and B's. Here's how to read it. A valid language is an A followed by one of two things, either nothing at all
or another valid language. And then the whole thing is closed off by a B. That little piece in the middle, the recursion, that's the magic. And what do you know, when we actually test it with the list AABB, Prolog comes back and correctly says true. That one little recursive rule just neatly unwraps that whole nested structure, and we didn't have to write a single complicated loop or check anything by hand.
All right, now for an example that shows just how elegant this can be, reversing a list. The logic here is just, it's wonderfully backwards. It says, to reverse a list, first, go and recursively reverse the tail of the list, the L's part. And only after that's all done do you deal with the head, L, by sticking it at the very end of the result.
But wait, this is where it gets even cooler. DCGs aren't just for checking if something is valid. They can actually build things. We can give it the string hello and a variable, rs, and basically ask it, hey, can you solve for rs? And Prolog uses that same reverse logic to figure out the answer, OLLA. We've gone from just validation to transformation, and all from just 2 lines of code. So, being able to recognize and transform lists is already pretty powerful stuff. But the real superpowers? Those get unlocked when we start adding our own arguments to these grammar rules. This is how we level up from a simple parser to a full-on structure-building machine. This is the next big leap you have to make. Those extra arguments, they aren't just for the hidden engine. We can add our own. And by adding our own arguments into our grammar rules, we can build really complex data structures on the fly as we parse. The classic example, of course, is building a parse tree to show the grammatical structure of a sentence. Take a look at this modified rule. We've added our own variables, NP and VP. Now, the rule still means a sentence is a noun phrase followed by a verb phrase, but now it has a second job. It also says, whatever structure the noun phrase rule builds, put it in the NP variable. Whatever the verb phrase rule builds, stick it in VP, and then combine them into this final structure, S of NP, VP. And this is what you get. When we run this fancier grammar on a sentence, we don't just get true back. We get a whole data structure, a parse tree that actually captures the deep structure of the sentence. We've officially gone from simple recognition to some serious structural analysis. And it totally doesn't stop with parse trees. You can use those extra arguments for almost anything. You could enforce grammatical rules, like making sure your subject and verb agree. You could carry around semantic information. You could count words or elements. You could even implement context-sensitive grammars, which are things that are basically impossible with simpler tools. Okay, let's pull all of these different threads together for a second and kind of reframe how we should be thinking about DCGs from now on. So here's the biggest takeaway, the thing I really want you to remember. Don't just think language parser. You gotta think bigger. DCGs are an incredibly powerful, declarative way to describe any problem that involves sequences, state, or structure. This isn't just for English sentences. We're talking file formats, communication protocols, maybe even genetic sequences. Anything that has a defined structure is a potential candidate for a grammar. And that leads us right to our final question for you. Now that you've seen the hidden engine and the real superpowers of DCGs, the question isn't just how do I use them? It's where can I use them? What problem are you working on right now, or just thinking about, that could be completely reframed and maybe, just maybe, elegantly solved by describing it as a grammar? Thanks for joining us on The Explainer.